Chapter 7, Trigonometry and Modelling. Lesson 1, Addition Formula. The addition formula, or compound angle formula, for sine, cosine, and tangent are defined as follows. The sine of a plus minus b, is equal to sine a cos b plus or minus, for the inside sine, cos a sine b. The cosine of a plus minus b is equal to cos a cos b minus plus, so the other sine, sine a sine b. And then lastly, tan of a plus minus b is equal to tan a plus minus tan b over 1 minus plus tan a multiplied by tan b. And you can prove these geometrically. Let's do an example. In the diagram here, the angle BAC is equal to alpha, and the angle CAE is equal to beta, and AE is equal to 1. Additionally, the lines AB and BC are perpendicular, AB and DE are perpendicular, EF and FC are perpendicular, and AC and EC are perpendicular. Using the diagram, prove that sine of alpha plus beta equals sine alpha cos beta plus cos alpha sine beta, and then that cos alpha plus beta equals cos alpha cos beta minus sine alpha sine beta. We can split the diagram into the 4 separate triangles in the diagram. For the triangle ADE, we can see that the angle here created is alpha plus beta, and the length AE equals 1. That means that the length DE is equal to sine of alpha plus beta, and the length AD is cos of alpha plus beta. For the triangle ACE, we can see that AE is 1. And so for the angle beta, EC is equal to sine beta, and AC is equal to cos beta. For the triangle ACB, we know that AC from here is cos beta, and the angle here is alpha. So CB is equal to sine alpha cos beta, and AB is cos alpha cos beta. And then for the triangle EFC, we know this angle here is alpha, which means that this small angle ACF is also going to be equal to alpha. And because this is a right angle triangle, that means angle ECF is 90 minus alpha. And because this is a right angle triangle, that means this is also alpha. So the angle CEF is alpha. And we know that EC is sine beta. So FC is sine alpha sine beta, and FE is cos alpha sine beta. So for part A, sine of alpha plus beta is equal to DE. DE is made of DF and FE. DF is the same as BC, which is sine alpha cos beta, and FE is cos alpha sine beta. And so therefore, sine of alpha plus beta is equal to sine alpha cos beta plus cos alpha sine beta as required. For part B, we can see that cos of alpha plus beta is equal to AD, which is equal to the length AB subtract the length of DB. We know AB is cos alpha cos beta, and we know DB is equal to FC, which is sine alpha sine beta. So this is negative sine alpha sine beta. And so therefore, cos of alpha plus beta is equal to cos alpha cos beta minus sine alpha sine beta as required. Let's do another example. Using the results from the first example, let's show that cos of A minus B is equal to cos A cos B plus sine A sine B, and then tan of A plus B is equal to tan A plus tan B over 1 minus tan A tan B. For part A, all we're doing is replacing B by negative B in cos of A plus B. So the cos of A plus negative B is the same thing as cos A cos of minus B minus the sine A times sine of negative B. Now, cos of minus B is the same thing as cos b, and you know that from year 1. And the sine of negative b is the same thing as minus sine of b. So we can simplify cos of a minus b is equal to cos a cos b. Negative, and a negative makes positive. So it's plus sine a sine b as required. For part b, we know that tan is the same as sine over cos. So tan of a plus b is equal to sine of a plus b over cos of a plus b. And using the addition formula, sine of a plus b is sine a cos b plus cos a sine b over cos of a plus b is cos a cos b minus sine a sine b. Now we want to get this into the form of this. We can see the denominator has a 1 instead of a cos a cos b, and it has a tan a tan b instead of sine a sine b. How can we get from this to this? We can see that we can divide by cos a cos b, but if we divide on the denominator, we have to do the same on the numerator. So it's going to be equal to sine a cos b over cos a cos b plus cos a sine b over cos a cos b over cos a cos b over cos a cos b minus sine a sine b over cos a cos b. We can see here that the cos b's will cancel out and we get sine a over cos a, which is just tan a. Here we can see the cos a's cancel out and we get sine b over cos b, which is tan b. The cos a's cancel here and the cos b cancel here, and we get sine a over cos a, which is tan a, multiplied by sine b over cos b, which is tan b. And so we get tan a plus tan b over 1 minus tan a tan b as required. Let's do one last example. Given that 2 sine of x plus y equals 3 cos of x minus y, express tan x in terms of tan y. Expanding this, we get 2 sine x cos y plus 2 cos x sine y is equal to 3 cos x cos y plus 3 sine x sine y. We want tan x, so we want to get rid of all the cos x and turn the sine x into cos x by dividing by cos x, because tan x is equal to sine x over cos x. And we also want to get rid of the cos y's and turn the sine y into tan y. So let's divide everything by cos x cos y. If we divide, we get 2 sine x cos y over cos x cos y plus 2 cos x sine y over cos x cos y is equal to 3 cos x cos y over cos x cos y plus 3 sine x sine y over cos x cos y. Here we can see that the cos y will cancel out, cos x will cancel out, cos x cos y will cancel out, and so we're left with 2 times sine over cos, which is 2 tan x, plus sine y over cos y is 2 tan y, is equal to 3, because that will cancel to 1, plus sine x over cos x is tan x, and sine y over cos y is tan y, so we get 3 tan x tan y. Rearranging, we get 2 tan x minus 3 tan x tan y is equal to 3 minus 2 tan y. We can factor out tan x and get 2 minus 3 tan y is equal to 3 minus 2 tan y. and dividing by 2 minus 3 tan y, we get tan x is equal to 3 minus 2 tan y over 2 minus 3 tan y. And that is it.